Hey everybody, welcome to the Tone Church. You are coming into this episode already in progress. The Tone Nun was running around making a bunch of noise, so done a little bit of work, but not much to see here. This is part 2 video. This is going to be the heavy industrial work, drilling holes and cutting out sheet metal and stuff. Just kind of the planning and plotting. Anyway, so part 1 we squared away the cabinet. Part 2 we're going to square away the chassis. Alright, so here's our chassis. I did spray paint it white. It's going to have to be painted again, obviously, because there's going to be a lot of that all over it before I'm done. But that's okay. What have we done? So it had a square hole in it already for a laydown transformer, but it wasn't big enough. So what we did is we did some very expensive measuring tools, and we measured the transformer, and it's got painter's tape on there to not scratch it up. And we did measure, and we made a little template, put it there, drew some lines, got the skill saw, made a bunch of noise, cut that out. Now this sucker fits in there nicely. What else have we done? We're going to reuse this hole in the chassis here for the power cord. And there was another hole right here, and that fits a fuse perfectly, so that'll be nice. And this is the back of the chassis, so that'll be easily accessible. So the power cord will be coming up here, and we'll have our little fuse right there, power transformer. That's all working good. And now, what else have we done? We've got this 2-inch wide piece of flashing, aluminum flashing. I think it's like 18 gauge. It's very easy to cut with tin snippers. And that is perfect because this is a 2-inch wide chassis, so this will be nice, right? And so now I'm just planning how this is going to work. We got 2 holes here for jacks, perfect. And I've been measuring and planning, P for pot, so we'll have one there and one here. So this will be the normal channel, volume and tone, and we'll have 2 more jacks right here. And those are the same distance apart. And then I measured out. I'm going to cut a hole here for volume, tone, and then we have the 2 controls for the tremolo, vibrato, tremolo I guess. And then finally up here we're going to need a switch and an indicator lamp. Alright, so what I'm going to do now is just cut the holes for the pots and jacks, and then we're going to mount this guy back up there. I've only got 2 screws, or 2 holes for screws so far for this thing. So we'll cut all the holes, then we'll screw this guy down, and then we'll go in and we'll mark out, you know, where we need to drill holes through this for all the stuff. And one thing we learned from the last build is we'll drill the final screws. There's obviously going to be more than 2 screws on this thing, but we'll add those once everything's all set up. That way, last time I put screws in the middle, like here and here, but I also had a potentiometer there, and the chicken head knob kind of got hung up on that screw. So the option was either don't use chicken head knobs, use smaller ones, or it'd have to be high on the shaft so it'll go over it. So, you know, we learn from our mistakes around here. And we make plenty of them, so we're learning a lot. Alright, that's where we're at. Wish me luck. Here we go.
Get it on!
Tell you one thing, aluminum is an excellent conductor of heat.
Feeling hot, hot, hot.
That's for damn sure. Alright, glad that's over. Got all the holes drilled in the front of the chassis and the faceplate. Now we're going to start making some decisions here. What else do we need to do? I always forget something. Oh, the speaker jack. Yeah, it's no big deal. We'll figure that out later. What are we going to do? We're going to do this with a circuit board, turret board. We're going to do this point to point. I mean, a turret board is certainly easier to do, but that doesn't really distinguish myself from every other tinkerer out there. So I think at this point we're forced to do it point to point, just so we can be frickin' special.
You are not special. You are not a beautiful or unique snowflake. You are the same decaying organic matter as everything else.
It's a pain in the ass. There's a reason why nobody else does that. But, you know, gotta do what you gotta do, I guess. So yeah, you just start figuring out how all the junk is gonna be arranged on the inside. And then we'll, get our chassis knockout punches and knock out the, holes for the tubes. And, why do I do this? This is like work. But, I actually can't wait to hear this sucker. When it's all said and done, it'll be worth it. Just you wait and see. Alright, so I am going to solicit the help of Mr. Pointer to help us figure this out. And I think because of the frog in my throat,
my identity will be safest if you never see my face.
and the size of the chassis and just the, you know, the amount of space that all the controls take, a strict point-to-point build, like 100% or 95% point-to-point build, is just unfeasible. So what I'll probably end up doing is adding several tag strips here and there to help facilitate the construction of the circuit, which will be fine. I mean, it would be a lot easier to build a turret board, but I just don't feel like building a turret board. I don't feel like waiting to order one either, if there is even... Well, you can go to, I think it's Hoffman Amps, and he'll build you anything you want, but we'll do what we'll do. So, if you're doing something like this at home, you probably shouldn't, because this is dangerous as hell with all the high voltage, so this is for entertainment purposes only. But what we need to think about is we can't forget about our output transformer. And we're going to make sure that the two transformers are off axis, so, you know, the power transformer, the long way, is like this. So we don't want to install the output transformer like that. We want it like that. So he'll probably be over here somewhere, maybe. Or we may stick him near the power tubes, because this is going to be the rectifier tube. We'll have our power supply filter caps and reservoir caps right here. So the only thing these wires are going to is the filter supply and the power tubes, so that'd be a nice spot for it. And then, you know, these are for the speaker jacks, or speaker jack. Anyway, what else do we have going on here? Take a quick look at the schematic here. We have two sets of inputs, high and low normal, high and low bright. Each side uses one section of a 7025, also known as a 12AX7. So normal goes into one triode, bright goes into another triode. Then they both have volume and tone. Then they go into one half of another 12AX7, which is another gain stage. And they both get mixed in right here and then go into the grid of that 12AX7. And then this goes into a third 12AX7, which both triodes are used to make a long tail pair phase inverter. And then off of here, we have this unused triode from this tube here, which is actually being used down here for our tremolo. Alright? Are you with me? And that is hooked up to the grid of the power tube, so we're you know, raising and lowering voltage, something like that, of the signal going into the grid of the power tubes. It goes out. We get a power supply GZ34. That's incorrect terminology. We're in America. It's a 5AR4. Get it right, Leo. My phone's telling me I am logged out of WhatsApp. So, I think that's a good thing. I don't know where I'm going with this. So that's where I'm at. I guess, yeah, the thinky part is, you know, takes up a lot of time. Because if you don't think enough, you start cutting big giant holes in your chassis that don't end up working, and then that's a bad thing. We're going to have a... See? While we're thinking about it, got to remember this guy. This is going to be for setting the bias. It's a bias trimmer. Oh yeah, and then I bought these guys. I might put some fuses in for the B+, high tension line, and possibly the heaters, and then the 5-volt heaters, 6.3 volt heater and 5-volt heaters, maybe. Along with the main fuse, right here, the mains fuse, in the primary of the power transformer. Trying to step things up a notch. Trying to be professional around here.
I'm acting like a professional.
Alright, let me get back to thinking. You guys are disturbing me. I can't think with all this disturbation. I'm not even going to touch that. I know the term. Mental masturbation. That's the term we were looking for. Alright, got these guys for filter caps. It's 2-in-1. F&Ts. Can we read that? What do we got here? 16 plus 16. So 2 sections of 16. And if we look at Leo's drawing here, they have 1, 2, 3, 4 nodes of filtering. 3 16s and an 8. This guy will be bumped up to 16. That'll be fine. So we gotta add these guys to the equation too. And then maybe a few of these guys for the aforementioned fusing of the different parts of the power supply. Just to make things a little bit more
Professional.
complicated. But I've got dinner here, because we can't be thinking without an empty stomach. Speaking of masturbation, the Tone Nun is a native of Brazil. She's a Brasileira. And this is Brazilian food right here. I believe this is a kibe. This is a coxinha. Good stuff there. If you ever have a chance to do try some of that and you haven't before, I like the kibe the best. But coxinha is nice too. Check them out. Give them a taste. Give them an eat. Alright, back to the mental masturbation. Alright, while I'm thinking about it, if you are trying to mock up, you know, a circuit like this, if you don't have your transformer installed, it's good to put the template there so we don't get this guy too close. And we don't want the rectifier too real close to the transformer anyway, because the sucker gets hot and we don't want to heat up the transformer, so we'll have to keep that in mind. And then the other thing is, you got to remember about the speaker underneath the cabinet. You know, I already checked it out, and there's plenty of room between the bottom of the chassis and the speaker. I mean, the only way we'd probably have a problem is if we put like the power tubes like way up to the front right here, directly over the center of the speaker. But if you have a smaller cabinet, that's something to look out for sure. All right. And along those same lines, a lot of cabinets will have like a shelf that the chassis slides on, or cleats it sits on. This particular one, only the front up here sits on top of the speaker baffle, and then there's a couple of cleats that the speaker baffle screws onto. So we can't put anything here because this is where it's sitting on those cleats. So I was just thinking about where to put these guys, and I was thinking maybe right there, but as you can see, this is where the cleat is. Well, that won't work, which is too bad because that would have been a nice little spot right there, but we'll keep thinking, we'll figure it out. Alright, I was going to talk about this in the next video when we start soldering, and get finished with all the mocking up and, you know, the mechanical construction of the big chunky physical components here. But the transformer, the power transformer I got is this guy here, the 290BX, and it's by Hammond, and this is for like a Blackface Deluxe, and they don't really have one specifically for the, you know, 6G3 Brownface Deluxe. I believe the Brownface has a little bit lower B+ voltage. You would have to go to like Mercury Magnetics to get a more appropriate power transformer, which would be fine because they make absolutely beautiful transformers, but you know, they're twice as expensive. Hammond are very good, but you know, why are Mercury twice as expensive? Well, you can see on these wires it's got, you know, black spray paint. You know, that's one thing. That's just a cosmetic thing. You know, but Hammond make very good transformers. Is it worth paying double to get a Mercury? I don't know, is money an object?
Money's no object. How much would you like? You haven't got that much!
The Mercuries are, you know, absolutely gorgeous, aesthetically looking for sure. Anyway, looks like the original for their negative bias supply, they're just tapping off one side of the B+, and they get a 100K resistor lowering the voltage. The original power transformer didn't have a dedicated winding for the negative bias. This transformer does have a dedicated wire. I believe it's this blue one here. It's a 50 volt winding. So what we're going to do is, what are we looking for? This guy here, we're going to take a little bit out of the Blackface schematic. As you can see right here, we do have a separate winding for the negative bias supply. Alright, instead of having a 100, what was that, 100K? Something like that? Yeah, 100K resistor, dropping resistor. This only has a 470 ohm dropping resistor. And we have the trim pot to fine tune the bias, negative bias. So, with that in mind, we need to just account for that when we're setting things up, and we're going to need this guy here, you know, somewhere in this vicinity with the filter caps as well, and it's a 50 volt rated 25 microfarad capacitor, which is a little guy, but we're going to need this guy here, and then just use that. Keep that in mind as we're setting up our B+ and, you know, our heater fuses. May or may not add one for the 5 volt heater. We're going to use protection diodes on the rectifier tube. So if we can't fit a fuse in for the 5 volt winding, that's not the end of the world. But I definitely want to have one for the B+ and the 6.3 volt winding. A lot of thinking going on here. Alright, one little thing I noticed here is the way this tremolo works is this tube oscillates, basically this tube oscillates the bias, which seems like a horrible idea. I imagine this design didn't last very long. But anyway, yeah, so let's compare it to this guy here, if we can get him in focus. Here we go. So this design here has a light-dependent resistor, 2 triodes, and the oscillation is getting injected up here between the second stage of amplification and the phase inverter. And if we look back here, this is completely different. This is just varying the bias of the power tubes.
2,000 years later.
Happy Sunday, everybody. Welcome back. It's been a couple of weeks since that last clip you saw. did a couple other projects, but we're back at it. Here we go. So I've been thinking about this and what to do about the negative bias, because we talked about how the transformer that we're using has a dedicated winding for the negative voltage. And also the power transformer. So like a Blackface Deluxe, the B plus right here is 415 volts. But right here, the transformer has virtually identical output on the secondary. I think it has 330 volts, which is what our transformer is putting out. So I'm thinking either the fact that they're cooking off a bunch of voltage here, creating a bunch of heat through this 100K resistor, might have an effect on the overall B+, but also probably more likely, or maybe a little bit from column A and a little bit from column B, like the AB763 Deluxe Reverb has 2 extra tubes in it, so it's very possible that they have a beefier power transformer, and that's why, you know, they're able to get a nice high B+ up there. But I think I've changed my mind on what we want to do here. I think we're going to go standard. We're not going to use this winding. We're just going to come off of one side of the secondary, high voltage secondary, and go through a 100K resistor. You know, for that reason, thinking that that's what's going to get a lower voltage on the plates and throughout the rest of the system here. Plus, we don't want to reinvent the wheel, and, you know, this setup, you know, might be responsible for this amp's magic. You know, it's sort of like a Telecaster bridge. You know, it's 3 hunks of brass that don't intonate worth shit, but, you know, everybody loves the Telecaster and they sound great. So hopefully that logic makes sense. What we did find, though, is this schematic here, and they've implemented the out of focus in the shadows trimmer pot for the bias. So we will do that, but they're using the 100K 1 watt resistor here for their negative bias voltage. And the door is creaking. I think we are being visited by a ghost.
And no ash grabbing.
Alright, anyway, so yeah, back to the thinking on how we're going to lay this out, and going to make some decisions and just start working. So here we go. Alright, I think this is what we're going to do. Get a Goodyear blimp version of this shot here. So we'll have the power transformer here, obviously. Go to the rectifier tube. Alright, and then the B+. It's going to come off the rectifier tube, go through this fuse, and that'll be right here to go to our filter caps. The 6.3 volt heater windings will make their way over to here, be fused, and then go up to here, and then also the heaters for the rest of the tubes. Oh, Jesus, I had it perfect. What else we got going on here? Here's our negative bias right here. And that's sort of close to all this stuff where it needs to be. And then it's going to end up going through here, which goes to the tremolo controls over here. All our filtering, we'll have the dropping resistors mounted to those lugs there. And over here, I think I can make this work even with the vents there, but we want the first tube to be in between the 2 sets of input jacks. So these 2 will go to one side of the tube, these 2 will go to the other side of the tube, and that goes to here, one half of here, and the other half of here will work the tremolo circuit. Finally, they end up here, which is the phase inverter, which is right next to the power tubes. Look at this guy here. We can have a switch to change the secondary of this, depending upon what we hook, what kind of speaker we hook up to it, 4, 8, and 16 ohms. And then we have a bunch of space in here for tag boards so we can, you know, get our circuit on. So that's what we're doing. So I'll pencil this stuff in, and then we'll break out the chassis hole punches and punch the holes for these tube sockets. And then we'll start mounting this other crap, and we'll be on our way. But that's going to be part 3 video. Let's get the holes in here for these guys. Put the transformers on. Yeah, put the transformers on. Drill a couple more holes, and that'll be it for part 2. Almost there. Alright, can you see all that? Everything marked up. Here we go. No turning back now. Oh, ding 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 dong. Ding 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 dong. This is extremely tough metal. And that is the wrong wrench. But if I had to do this with drill bits, probably would have burnt through about 100 of them. Alright, what's the problem here? Why aren't we grabbing? What are we through? We're through. We did it. You see that? That's the hardest one of the bunch right there. Where the hell? Where are all the tube sockets? How the hell does this happen? There we go. Yeah, here we go. You see that? And on this side, yep, that'll be perfect. Alright, that's the hardest one. 5 more to go. Uh-oh. Oh. So, let's see here. We're going to put this on the inside of the chassis, this one, because this lip will mar the surface. So we'll have the pointy end on the underside or the visible side. And let's see here. This is, ooh, might not be able to turn the wrench if we have it this way. If we can't do it this way, no big deal. We're gonna repaint this anyway once all the heavy construction is done. Let's see what we got here. Yeah, it should be alright. This guy isn't doing anybody any favors. Here we go. Oh yeah. It's tough getting it started, but once it gets going, it gets easier. Holy crap. Hopefully. Right now. I see some edge. Jesus. Dang, dude. Alright, we got ourselves a handle.
Some of you might think this is funny for sissies, so, go ahead and laugh now.
I don't know why this is being such a bitch. Never had problems like this before. Must be some kind of, kryptonite steel. Oh yeah, that's better. Alright, much better. Oh yeah, much better. There we go. This thing out of the way. There we go. Jeez, I don't know why that was such a pain in the ass. Because the drill went through it pretty easily. Didn't give me any indication that this would be a real problem to punch holes in, but I guess looks can be deceiving. Alright, what do we got? 4 more to go. Alright, glad that's over. That was rough. 1, 2, 3, 4, 5, 6. What I ended up having to do is hold it like this on the floor, and I steadied the wrench, and then I had the tone nun climb up onto the back of the sofa.
He's climbing the outside, going to the top turnbuckle,
and jump onto the wrench.
He's climbing to the top of the steel cage.
And that would twist it a little bit, and then she just kept jumping off the couch again and again and again.
Superfly perched 15 feet high.
And here we are.
Oh my!
So special thanks to the tone nun for that. Let's move on. Alright, we're moving right along here. The octal sockets are installed. And I only installed the one bear trap for now. It's temporary. I'll put those other bear traps in when I'm done, because I want to use the bias tester. If I can get it off the wall here. The bias tester, and you can't get, well, this is one of my ugly homemade ones, but you can't get it into the socket if the bear trap's on there. So those will probably be like the last thing I do is put the bear traps back on. Anyway, when we orient these things, we want to plan ahead and think of, especially with a point-to-point or semi-point-to-point build, you know, where the components are going to hook onto the socket. So for example, like the rectifier tube, pins 2 and 8 are for the cathode, and those are going to go to the power supply. So we have those oriented. We got pin 2 and pin 8 on this side of the tube, so they're going to be going towards the power supply. Same thing with like the first preamp tube, the grids, which is pin 2 and 7. So I kind of got it so that the 2 input jacks will be going nicely into that first tube, if that makes sense. Not the biggest thing in the world to do, but it's a nice consideration to do. And same thing with this third preamp tube. Let me get a better marker here. This will work. So the plates is pin 1 and pin 6. So we got pin 1 right here and pin 6 up at the top, and those are going to be going to the output tubes. So I've got it so that it's kind of equidistant. Don't have it facing away from the output tubes. Hopefully that all makes sense. So we'll make some marks here and show you what we're doing here. And I tried to center it to the hole because there is some play the way this sits. But you know, if it was too far this way, we would just cheat it with the drill in the opposite direction, which we'll probably do because this guy's a little bit close. So we'll cheat this one a little bit over there, that guy a little bit over there, blah blah blah, drilling holes. But yeah, she's coming along. Oh, I gave her another coat of paint. Looks nice, right? Hopefully I don't wreck it between now and when I'm done. But I'm going to break out the drill and get the rest of these sockets in there. Alright, got the holes drilled for that. On the octal sockets, we use 632s. On the 9-pin, we use 440s. And instead of buying a million different sizes of screw, I'll use this right here, which are wire strippers, but I don't use these to strip wire. I use these for this part right here, all these little holes. They're threaded holes. And what we do is we screw the screw down into the hole.
That's what she said. Oh, no, not that. Just come on, you guys, let's do it.
And I leave the amount we're gonna need. So the, the height of the nut, the thickness of the chassis, and the thickness of the tab on the socket. Leaves it about that amount exposed, and that should be perfect because we're gonna have a little bit more due to the thickness of the jaw. So right about there, then we give it a little squeeze. And then when you cut it, the tip of the screw might be a little jaggedy and sharp. And it might be difficult to thread a nut on there. So we just go forward a little bit, and then we back it out. And that should form it up nicely. Should be pretty good. And there we go. Got a perfectly sized screw. And here we are. And we use lock nuts, and we also use the star nuts, or caps nuts, for all the stuff we mount to the chassis. We really don't want anything coming loose. For tube sockets, I'll use the lock nuts, and for anything that has an electrical connection, like if we're mounting a tag strip or a single tag that we were gonna, maybe tie a ground to, I'll use the star nuts or the caps nuts. Alright. Fascinating stuff. Okay, we've got all of our holes for our output transformer. And for the wires to go through the chassis, these are 1/2-inch holes, and we're going to use grommets. Anytime you have wires going through a chassis, you have to have some kind of grommet. Because you can imagine you got high voltage going to the, the primary of your output transformer, and if it's going through a metal hole like this, you're playing guitar and it's vibrating, could abrade the insulation and send, 600 volts to the chassis. It would be quite the smoke show. While I was drilling this, obviously the metal chips are very hot. It melted the paint a little bit. So we're just going to touch that up and continue on. And here we are. Pretty much all of the chunky stuff is installed. Looking pretty good. This is very much in the style of like a Valco, a vintage Valco, or possibly a little bit even like a modern top hat amplifier. Using tag strips like that. We'll see how it ends up. But that's it for all the chunky stuff. Ooh. Yeah. Starting to look like a real amplifier. Alright, that's going to do it for this video. Sunday night. Gotta hit the day job tomorrow. Here's a cool car. BMW M3. The ultimate driving machine. Oop. Oop, little scratch. Ow! And this is an example of what not to do when your car's about to get repossessed. Nice. You're gonna be paying for that. So hopefully we'll see you next weekend. Maybe possibly 50% chance of rain. When we start breaking out the soldering iron and sticking all the resistors and capacitors and all the other fun stuff in there. So I hope you enjoyed the video. Thanks for watching. Thanks for one of these if you give me one. And we'll see you in part 3. Rock on, dudes and dudettes.
Done.